Hi, I'm Dave Robinson, and welcome to another screencast where I'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes to the Tidy Tuesday project, an amazing weekly data project in R, run by the R for Data Science online learning community. And as usual, if you're joining live, I'd be really excited for you to join in, ask questions, give ideas for visualizations I might not have thought of. I can read everything, and it's one of my favorite parts of doing these live. So, let's see what we've got this week. Looks like it's the Bechdel test. All right, looks like 538's written about this before. So the story of the Bechdel test is that it's a test produced by a cartoonist, Alison Bechdel, that says that if a movie can satisfy three criteria, there are two named women in the picture, they have a conversation with each other at some point, and the conversation is not about a man, then it passes. So the question is what kind of movies pass this test. I don't know if we're looking at movies here. Yes, I think we have raw data and then some process data. I don't know what the difference between these two is. I think the process data movies has been enriched with a lot of other information. We actually looked at the Bechdel test for something else before. It was the X-Men. It was what was it called? The Claremont run, I think, on the X-Men. There was a series that was well known for its gender representation. So it's not the first time it's popped up in Tidy Tuesday. That was a really fun analysis on X-Men. I recommend it. So let's do this. Let's do Tidy Tuesday R. Use Tidy template for today's date. I usually like to do library scales, theme set, theme light. I really need to customize this template. I think I'm mostly going to be working off this enriched movies dataset, 1,800 movies, and we're going to ask questions like, I think this is pass or fail the Bechdel test. We're going to look at other things like the budget, and actually if I type TT, I can see all the other pieces of information that I have here. Is IMDb okay, it's like a URL or an ID. All right, so we got, really lots of info on these 1,800 movies. Yeah, and do I need to clean anything from it? I don't think so. I think this looks pretty good. All right, so the test is, okay. There are a couple, so there's pass or fail, and there's a couple types here. It's my understanding, I can see if I can find this. Here it is. I'm looking at I'm seeing if I can find this. My understanding here, let's do movies, count, clean, test. My understanding is it goes, okay means it passes. No talk presumably means that female characters don't talk. Men means they would talk about, the only time they talk about men. That's the reason it fails. Dubious, no women would mean no female characters. And I don't know what dubious means. Maybe it means it's a borderline case, like there's disagreement. If I filter for dubious, I'm not seeing dubious. Dubious disagree, dubious disagree. It's counted as fail. I guess these are situations where, say, it's unclear if the conversation is about a man or between two named characters, something like that. That's my understanding. But it looks like it is counted as a fail in terms of the binary. Okay, so we are going to explore some of the reasons that these fail. But first, we can kind of work with the binary. We have budget. We have domestic and international gross, coded, I guess, by year and whether it passed, failed. We have the, I guess this is budget in 2013 dollars. Let's take a look at this. Yep, normalized 2013. I guess the idea is this analysis must have come out in 2013. So you have the domestic gross, the international gross, the period code. I don't know what that means here because because we don't have the information here. Let's see. Okay, I bet period is divided up into something like 5 years or something like that. Decade is definitely coded. And the how different are, I think I can make a couple graphs to understand that. There's a plot, there's a rating, there's really lots of response. Is that whether character response. I don't know. I don't know. Something to do with IMDb, because notice the ones that have false response just don't have the other piece of information. There's language, there's country. Oh, yes, so somebody enriched this with a lot of useful IMDb data. We can work with ratings, we can look at genres. That's going to need some nesting. Oh, I'm excited. Let's get started. So the place that I would start is probably looking at over time. So I would do count year. Do we have year? Great. Count year and binary, pass fail, and we might visualize year binary, year n fill equals binary. So this would be like the how many movies pass and fail within our data set of 1,800 movies. This at least shows like, okay, there's not a huge difference over time. We're getting more movies rated, and it's fairly similar proportion. I might want to do this by group by decade is 10 times, what do? I do floor, or no, I do 10 times year truncated division by 10, summarize, and movies, n PCT pass is mean binary equals pass. Okay, so there is a difference. It was a little hard to see on this one. So it's decade, geom line. I always want x equals 0 when I'm putting a percentage on the y-axis. Not always, but and it looks like I have something wrong in the. Oh, I meant to say y equals 0. There we go. And I might want something like geom point size is n movies. Yeah, so it mostly sees like, okay, we don't have a ton of movies from the 1970s and 80s. A lot of them failed. Comic came out in 85, and hey, maybe things have gotten better since then. So it looks like most movies don't pass, like from the 70s and 80s. Recently, it's maybe a little under half. Okay, so that's our change over time. It's notable enough that for some analysis, I might want to filter for just since 1990. Most of our movies are since 1990. I don't want it to be confounded by the factors. It's a possibility. Like if I said year 1990, greater than or equal to 1990, that's 1,600 movies, and I'm probably still in pretty good shape. Okay, then I might want to find out things like, well, I have descending domestic, or let's say. Let's look at actually the most money-making movies on this list. Descending, which movies made the most money? So descending international gross in 2013 terms, and we do title, budget. Something's wrong with this column. Yeah, something's up with it. Oh, look at this. These columns are character. Let's see how many of those we have. That's why I was getting these weird 9s on top. So this is character, this is character. Anything else? Nope, doesn't seem too bad. So what I do is I go back to the cleaning step, and I do a mutate across, contains int gross. Nope, no, it contains, I think all the ones that are grosses are character. So say if it contains gross, then apply as numeric. Actually, parse number, which is a little more, parse number from readr is a little bit more clear on this, like a little more flexible. So that's, I think, why I didn't read it in as characters. There was some odd values. How many odd values were there? Let's take a look. 18, 11, just not a ton. It's going to end up being, so these were NA, but we're an interesting kind of NA. So I can, adding this step cleans those out across. Great. So I use across a lot when I'm cleaning multiple columns at once. Now this makes sense. Okay, yes, the top grossing ones, adjusted for inflation, Titanic, Avatar, Jurassic Park. These are not necessarily the most money making of all time, just the most money making in this list. But I might be interested in like if I like to look at just like 25, say the top 25, and if I say something like, here's the in gross 2013. And the budget, and the title, geom call, and do a quick mutate, title is FCT reorder. I'm going to make a bar plot. So it's like Titanic and Arbor made the most, but the critical thing that I made a lot more than anything else, adjusted for inflation. But the critical thing is that I want to add fill is binary. Did it pass the Bechdel test? The answer is among the top money-making films, for instance, a little under half, yeah, less than half pass. Titanic, Jurassic Park, Star Wars, Sorcerer's Stone. Some of these pass, some of these don't. We're gonna look at genre later. I can really tell. I was gonna say a lot of them that don't pass are action movies, but some of the ones that pass are action movies, like Transformers: Dark of the Moon, and yeah, the so yeah, so we have some fail, some pass. So what is the general pattern in terms of is there a difference between movies that pass and don't based on inflation adjusted? Um, Actually, probably don't need the 1990 for this one, but yeah, if I do based on, and then that throws in ones like Star Wars that didn't pass, and Jaws that didn't pass. Star Wars basically has one female character in the first movie. Yeah, nope, Emperor, but she and Leia never talk. Anyway, but the yes, what I was saying was if we visualize. The way to visualize comparing like two distributions is typically a box plot. So I typically do something like int gross 2013 by binary box plot. I can tell with something like this I'm going to need a scale x log 10. So all right, so we can say, okay, overall these distributions overlap a lot. You know, looking at it, comparing only two that might be like maybe I'd rather have a geom density, just to really compare the distributions in a bit more detail. And geom density, let's see, fill equals, yeah, so this looks like, you know, looking at it, there is a difference in distribution. I wonder if I say filter for year, in that movies that pass, a little bit lower than movies that fail. A little bit, so if I filter for year 1990, still the same pattern. So it's not just say lots of movies in the 70s and 80s and made a lot of money were included on this list. So of course this doesn't indicate causation. It certainly doesn't indicate that failing the Bechdel test leads movies to be more popular. But we might think about, okay, we can think about what some of the confounding factors could plausibly be. For one thing, there's a ton of overlap here, but yeah, there's a shift. What does this work out to, I wonder, in terms of a linear model? Well, we could start by saying, we'd say, what is the log 2 of int gross 2013 explained by binary, explained by pass or fail? Data is movies. So statistically significant and minus 0.5. So that means it's on a log scale. It would move halfway along it. So this, remember, it goes all the way from a gross of 1 million, which is like an independent movie, to a gross of 100 million, which is a fairly successful movie. And the I wonder if I did domestic gross. How does the table look different? Dom gross 2013. And it's a little bit smaller. So remember, this is on a log 2 scale, so but it's not much smaller. It's still significant. But yeah, so int gross. So this could just mean that the kind of movies that get international gross and such tend to be, say, action movies. So I'm going to be really interested in. There are a lot of potential confounding factors here. I'm going to be interested in genre first. So let's take a look at movies, and let's count that genre. What is it? Genre. Yep. Have we worked with this data before? It looks familiar. I think we worked with something like this for horror movies once. What I can do is I can do separate rows. Genre. Sep is comma space, and separate rows is a great tidier function. It lets me now look at, okay, drama, comedy, action, adventure, etc. Really critical thing about this is that it's going to excuse me. A really critical thing about this is that they're going to be the same movie. It's going to be in multiple genres. So you can see action, adventure, sci-fi. So these are not exclusive. We can still work with it. We can still make this kind of box plot from it, where I might be interested in No, you know, that's a box plot. That's not the way that I'd want to look at it. I would want to group by genre, okay, and PCT and movies. PCT pass equals, you know, I'm going to keep finding myself doing this same pattern. So I'm going to go ahead and write a quick function about that PCT pass kind of thing. I love writing functions like summarize such and such. So then I can say, I can kind of keep applying this to whatever kind of grouping I want. And if I need to add other things to it, I can. You know, I can actually add, I'm going to say median int gross 2013. I'm just going to add the average amount of money. We might have an understanding of like maybe the genre affects both the Bechdel test and the gross. So I'm actually going to throw this in. I'll throw it in as median. I could have used geometric mean. Median is kind of easy to understand. Median. Oh, it's here it is. And you know, when I get that median, I'm going to need to do NARM equals true. And you know, I'm usually going to want to sort. So I like this, see, because I can say like, okay, depending on the genre, what's the probability of the passing the Bechdel test? So that's really critical here is when we talk about correlation and causation. We said earlier we're not going to think in terms of like we're not going to say, oh yes, movies that fail the Bechdel test make more money. That means that there's a causal link. So how do we investigate causal links? Well, it starts with this kind of causal reasoning where we actually might say like, what could we imagine? What affects what? I can really imagine that a genre does affect whether a movie passes the Bechdel test. In contrast, I would never say whether a movie passes the Bechdel test affects the genre. That's just not a causal link that I would describe. So we could say, okay, action movies could affect the Beck test in a lot of ways. It could affect it in terms of hiring directors and screenwriters that don't think about it. It could be that producers, correctly or not, think that people that go to action movies aren't looking for scenes of female characters speaking to each other. There are too few female characters. Either way, it does just make intuitive sense to me that you can see right here that action and adventure both had a lower have a lower percentage of the past Bechdel test relative to, say, dramas and comedies, which is close to 50-50, and a higher average international gross. So if I actually visualize this, I'm going to look at the top 10 most common genres, and I'm going to filter for not genre. And I'm going to say median int gross 2013 by PCT pass. Oh, and throw in a size equals n movies. And throw in a geom text. You know what? I like GG repel for this because I want to have every point have a label. Label is genre. And you know, I usually don't like the text to have a size aesthetic. I can put it just associated with the point. Let's do a little bit more work here. Let's say x equals 0 doesn't really work. No, x equals 0 works, y equals 0. And scale x. I could do log. I'm actually not going to do log in this one, but I will do scale y continuous labels equals %. And I'll add a little bit more labeling because I think this is a notable, this kind of tells my story. To the median international gross 2013 dollars. So I think this is what we can see. What we saw earlier, okay, movies with Bechdel test have a little bit of a lower, have a lower gross. I absolutely don't think that it's strictly causal. I think that it's a story of the most money making international, the most money making genres are action and adventure that are also the ones that most often fail the Bechdel test. In contrast, horror and romance tend considerably more likely to pass. Still not amazing, still just above 50%. And then drama and comedy. These are the generally lower grossing ones. The median adventure movie grosses 2.5 times that, and is less likely. So we can then we can then ask this question in terms of we can actually try doing this. Here you go, as like a linear model, where I can try saying, if we control for the genres, what's the effect on the what's the relationship between Bechdel test and the median international gross? I'll add a linear term or for each of these. So the way that I have to do that is I'm actually going to spread. I'm going to filter. This is fine. I'm going to spread. I'm going to, what I'm going to do is say mutate value is 1, spread genre value fill equals 0. So the story is now I have a column for every genre, and action, adventure, animation, biography, comedy, crime, etc. If I had tons of genres, like hundreds, I would do a lasso, like a regularized regression. I might still do that today. We'll see if we get into it. But the story is here that what I just did is I reshaped the data a little bit with a separate rows and a spread, where I actually just reshaped the data so that there's like a 0 or 1 in every column. So it's one hot encoded in terms of it's actually not quite one hot encoded. Could have multiple of these encoded. But now I can actually say, okay, well, what is the relationship? What is the linear model of log2 of int gross 2013 explained by, let's start with just explained by action. And data equals dot, because data is being passed into the pipe. And so it's okay, action movies tend to make more. Okay, throw in another one, adventure. Adventure movies tend to take more. I'll throw in the top 10. Again, this is a kind of silly thing that is like, it's a lot of manual typing. There are ways to shorten this, but by fantasy, comedy, drama, romance, horror. I just copied the 10 off these ones that I saw over here. And I also throw in binary, whether it passed the Bechdel test or not. Okay. So when we control for these, what we see is, looking at these, yes. The stories of something is fantasy, higher, does they have a higher gross, is on a logger scale, so there's quite a big effect. Action, there's a really enormous effect, more than doubles the impact. And then you have ones like drama that tend to have a lower gross. And then based on all these, okay, the Bechdel test has a weak correlation. It looks like maybe it's a negative correlation. Once you control for these top 10 genres, maybe it's kind of on the cusp of significance, as they say, like a p-value around 0.05. Okay, so so it's possible we haven't found all the right confounders yet. I'm curious about something. If I happen to say, I don't want to go hunting for effects, but if I filter for, yeah, so one thing is if I take a look at since 1990, which remember we saw there was an effective time. As soon as I do that filter, the Bechdel test doesn't seem to really have a significant effect. Still this coefficient, but it can't distinguish it from noise. So my guess is a lot of the relationship with this this negative impact that we're seeing on this this density plot, as Data Digest points out, here's the density plot. I suspect this negative impact is largely based on the genre. So we can actually visually inspect that. Oh, and also the 1990. So if I tried, I can actually say, plus add a term for 1990. And yeah, you see something similar as movies since 1990 have a lower international gross adjusted for inflation. It's not necessarily because movies are making less money adjusted for inflation. It could be that movies before 1990 tended to be, in this data set, were selected for the most money-making ones. I bet that's true. There weren't a lot of movies in the 70s, 80s. They may not have included a lot of independent films. So that's a confounding factor. So much so, honestly, that I think I just wanted to filter it to keep it out for almost any of these analyses that we do. So if I take a look at this binary, this effect, yes, there is this shift where movies that fail have a slightly higher gross. But I can also say labels, comma, it's like actually labels dollars, even better. No gross, $13. So I bet I can actually separate the rows out, the genre rows from this. So what I can do is separate rows. I can filter genre. I can always good to leave this in. I can say filter genre FCT lump of genre into the top 10, the 10 most common is not equal to other. You know, I can actually do 12. I'll do 8. This is a great way to say I only want the 10 most common, or the 8 most common genres, and then I can facet this density. Facet wrap by genre. You know, actually, I take it back. I like 9 on a facet. Aha, okay. So, are there still differences? One of the biggest things that we see action adventure movies, whether or not they pass the Bechdel, like conditional on something being an adventure movie, whether they pass the Bechdel test doesn't seem to have a big impact. In contrast, fantasy movies that fail might make a little more money than fantasy movies that pass. We don't know if these, how statistically strong these are. That's kind of the issue with looking at density plots this way. Let's try looking instead at, let's look at the same data, but here we go, but look at it as a genome box plot. Story here is going to say, okay, maybe there is a trend, maybe there's a trend where comedies make less than they pass. But I don't really think that's the case. Here we're actually getting really into that space where we might have to, where we don't have enough data to keep examining the question. But we can definitely see that there's no question from the linear model that the effect got a lot weaker once we understood that genres make different amounts. Genres make different amounts of money, and and they both affect whether a movie passed the Bechdel test. Particular directors or particular stories that producers want to tell less suited to it, and also tightly correlated with how much money the movie makes. All right, so that's how we can understand that that certainly it's not true that that if a movie passes the Bechdel test, that's bad for its box office prospects. There's just a few thoughts on like causal inference, but also on this kind of exploration. We should actually, but I would say that like this genre thing is really important. I'm actually going to here. I'm going to create this and call it. I'm going to create a data set called. I'm doing a little bit of rewriting here. I'm just thinking that this is the kind of thing that is really quite interesting. Yep, here's the plot, understanding how the confounding factor of genre relative to whether pass the Bechdel test and the gross. There's this visualization and this one, and then I might just also you know, I was starting to make a bar plot, but I'm starting to think about it. This is a pretty good, this is kind of how I'd want to get the idea across about movies that pass the Bechdel test. versus don't. I'm gonna include 12 points on this. Basically, I think it's not quite that there's a negative correlation. I wouldn't put it that way. Like among the movies, among this class of movies that typically makes under $100 million, there's genres like crime that only 25% pass, and horror where almost 2/3 pass. What we're really seeing is action, adventure, and I didn't say this, animation that make lots of money tend not to pass the Bechdel test. So that's one notable confounding factor. All right, that's some thoughts on genres in the Bechdel test. What should I look at next? I could look a little bit at the ways they don't pass. Yes, I'm a little interested in this. What I'm interested in is, let's do this, count, clean, test, remind myself of this. Cool, we can say, I'm gonna keep, actually, do anything since 1990? I'm gonna leave in the pre-1990 for now. Movie genres, and what if I say, yeah, I'm gonna count genre and clean test. And I'm gonna do that FCT, I'm gonna do FCT lump genre by 8. Why 8? So that I have 9 categories including other. So now I might want to understand what's the difference between each of these, the reasons that they might fail. So one way I can do that is clean test, geom call, and facet wrap by genre. It's not going to look quite amazing yet. You know, it could be worse. So this is saying like, you know what? Yeah, I kind of want to compare them with percentages. So I'm going to do group by genre, mutate, and PCT equals n over sum n. Remember that movies can be in multiple of these genres at once. PCT. So the story I'm asking here is, does the reason a movie fails the Bechdel test differ between genres? So here's a way that I think it does. Let's see, here, that's pretty good. Should we reorganize a different way? Right now it's like reverse alphabetical. Actually, I kind of like this ordering. I actually really like it is alphabetical. It's like pass, didn't have women, which is the most dramatic reason to fail. They didn't talk, second most dramatic. They talked about men, which is the last hurdle, and then this is like we're not so sure how to count it. So what do we think is interesting? Well, notice that romance movies almost never fail for having no women. Makes sense. Heterosexual romance movies would have at least one female character, and a lot of movies are made female for female audience. So you can mention multiple female characters, but it's relatively like when they do talk, they sometimes will fit. Now, romance still ranks pretty well in this spectrum in general, but it is entirely possible. It's much more likely that they don't talk or they talk about men. In contrast, like action movies, it's very common that female characters don't talk. Also, adventure, I think that's true in Lord of the Rings. Is there a handful of female characters, but they don't meet in the movie. And yeah, usually no talk is the majority reason. The exception is romance, kind of also drama, I think. What's the one where it's most common for there to be no women? Looks like action. In fact, that way of comparing them tells me I might want to try a different facet. I might want to try this. Genre reasons is the name of this table. I might want to flip these two. You almost always want to consider like flipping for these faceted bar plots, flipping the facet and the and the one that's faceted and the one that's percentage. I'm going to just drop dubious. Not interested in this visualization. And I'm going to do a little bit of reordering of the column. Genre dubious. Did I have this? What did I spell? Did I spell this wrong? Oh shoot! It's not genre. It's reason. It's cleaned test. Clean test. That's the one. Other thing I'm going to do is reorder these. I'm going to say scale y reordered and do mutate genre is FCT reorder genre. Reorder. Nope. The function I was looking for was reorder within genre PCT within clean test. I want each of these facets to have their own ordering. And I forgot, whenever I do that, I need facet wrap to have scales free y. So this might be a little easier to read. We can say like, okay, the ones that which ones pass to fail the most? Like romance tends to pass, action, adventure, crime tend to fail. But are there particular within reasons? It's like in romance is the most. Romance is the one where the largest proportion of movies fail because they never talk about a man, as opposed to the other reasons. So it doesn't hit that third criteria. That makes me think like, if I reorder this, I'm going to want to reorder this. Here's what I'm going to do. I'm going to say clean test is FCT rev. Here are your three conditions. And just because this happens to alphabetically work out that way by doing FCT rev, but then I can do FCT recode. So I'm going to say clean test, FCT recode, clean test. Think about how to like make this so I don't have to say all these words to explain it. So it kind of feels natural. I can say passes. Did I do this direction right? Yep, passes, and then we'd said has women who talk. Actually, now that I think about it, the fourth one should be passes. I'll recode it. I'll relevel this in a second. To each other. About something other than a man. So you notice it's just a little bit clearer this way, and I'm also going to want to like reorder this. I'm going to say FCT. I'm going to change this to re-level, which lets me give a couple steps to say I'm going to want to order it as the specific order I want is no women, no talk, men, okay. I don't actually need the last argument when I give it past to FCT re-level. Which step? See, this is where like just saying I'm going to create a faceted plot doesn't tell us much. The y-axis would have to be a genre. Just saying I'm going to do a faceted plot kind of like is not the main point. It's I want to say like I want to create a narrative. I want to read from left to right. Say it fails on has two women. Action is most likely to fail on that. Who talk to each other. Action also, a lot of action, crime, adventure movies fail on have two women that talk to each other. Something other men, that catches some romances and some comedies which have been on the relatively lower side of this. Thrillers, it looks like, well, a lot of them had already been taken up, but yeah, but romance they might not. And then there's the category of movies that pass. It tells us a little bit. It's not. I think it's not tremendous, but I think it's a interesting way to visualize this. The last thing I might want to do here. Do I want to do this? Yeah, I think I want to add. Nah, I was saying I want to add percentages to each of them, but it also occurs to me that these percentages are based. Some of them could be based on fairly low numbers, so I don't want to get too precise. We can kind of just eyeball them. All right. So, all right. So that's the look at genres. Do we want to take a look at? Yes. Here we're going to do it now. I'm actually going to look at the. It's been a while since I did text, and I'm going to reward myself. I'm going to look at the plot description. So we already loaded tidy text, so we can unknown nest tokens plot word plot. Count word. I can I might want to remove the anti-join. Stop words. Remove words like the, to, of, and here we go. So we can ask questions. So here might be the question I want to ask is, what kinds of words pop up in plot descriptions that make something likely to be to pass or fail the Bechdel test? I could have just done directors. Maybe I'll do directors. I should do directors. I'm going to do directors first because this I think is going to be mostly confounded with genre. This is probably not going to tell us that much. But let's take a quick look at directors. Is there only one director per movie? I think for the most part that's the case. Yep. So I can really only look at I'm going to keep it in other categories. Say filter not isn't a director. Count. So group by director. Remember I created this function fct lump director 9, and I mentioned this summarize Bechdel function. We can say, okay, I'm going to do only the top 8. Heck, let's do the top 15. Oof, too many ties near the bottom. What if I did 14? Is that going to be, yeah, sorry, what we're going to do is 8, and we get 10. The trouble is when you get ties here, it's fine. I'll just have 10. So the story is, yeah, these, because the problem is people tied in at 9, so I can't pick any of them. That's fine. So the question I want to ask is, like, of these directors, how often do they pass the Bechdel test? So for instance, wow, I am glad I looked at this, because PCT pass. The story is that, like, Woody Allen's movies usually pass the Bechdel test. Tim Burton's, like, at least 2 out of 3, 6 out of 9 in this data set do. Tim Burton's 6 out of 10. The other directors in this, we saw, a little short of half, but some of the most famous director and prolific directors of all time, Steven Spielberg, Martin Scorsese, really do not pass the Bechdel test. So Martin Scorsese had 12 movies, looks like only one of them passes the Bechdel test. Can I name that off the top of my head? Goodfellas definitely doesn't. Let me see. Taxi Driver definitely doesn't. Well, let's find out. Let's see. If I said descending, let's do descending year. So Wolf of Wall Street fails, Hugo fails. The only one that passes, I should have guessed this, Age of Innocence. That's a really great Scorsese movie. It's a bit different than his usual style. But Age of Innocence passes, everything else fails. So thus 8%. What about Steven Spielberg? Can I name it? I can never. I'm not gonna guess this. I'm not gonna put myself under pressure to guess this. Color Purple and Jurassic Park. Jurassic Park. Laura Dern and the kid? Must have been. I forgot the kid's name. Probably. That's cool. And Lincoln passes. Okay, so so 3 movies, but that's out of a really large number that most of which fail the Bechdel test. So that I think is one interesting visual thing. We could pop up visualization. I wonder if I did. A larger set. Yeah, like, we could pop a visualization. Everyone knows how to create a visualization from these. Um, and I might also want to say, let's look at the writer. Were there multiple writers? Yes, and they were often like screenplay, novel, etc. If I did a unnest, separate rows, because writer is probably more responsible for the Bechdel test than the director is. The separate rows, writer, and sep is. Nobody here has more than 7. I think it's just going to be a little tough to work with, but I can still do it. I can still say group by writer. I might also, while I'm at it, I might want to strip out the parentheses because it doesn't represent different people, it just represents different roles. And maybe that, so what I might do is separate the rows and then mutate writer as string remove. That's a regex, meaning parentheses and anything after them. Escape the parentheses. Yeah, so we can see like, so this is kind of useful. We can say overall it's like in the 40%. NA is not particularly relevant. Some of the top ones are, so some of the writers who have written the most screenplays include like Ted Elliott, Terry Rossio, all of them 16, like 0 for 16, these top 2. Who is Ted Elliott? I have to actually say string detect writer Ted Elliott because I did a filter thing on it. Yep, wrote I think Ted. Funny, there's 11. I thought there'd be 16. Or maybe Ted Elliott got multiple credits for some of these, so maybe it's not quite fair. But the story is still okay. He wrote all the Pirates of the Caribbean movies, Shrek, etc. No movies that passed. Terry Rossio. Looks like a writing partner of Ted Elliott. This actually occurs to me that I can fix this by saying once I've removed this, distinct title and writer dot keep all equals true. Here, Ted Elliott wrote 11. Yeah, I just want to make sure to get that clear. And then George Lucas 1 for 10, Stan Lee 2 for 10, etc. So that not quite enough like repeat writers in here to learn a ton from, and some from the directors. But those are some things we learned. But yes, let's do tidy text. We have 10 minutes, and let's take a quick look at these words. So, what kinds of words pop up in plot descriptions? Life, woman, world, family, love, story, war. I bet some of them are more common in some. Some of them are more common in some genres than others. But but I wonder if I said group by word. Let's see. Group by word is FCT lump of word and only take the top 50, let's say. 50 most common words. Summarize Bechdel. Before I do this, I will need to distinct word and title dot keep all equals true. Keep it 1 word each, otherwise summarize Bechdel won't work. And I could say, okay, the arrange descending PCT pass. What words tend to appear in movies that do pass, don't pass? Makes sense that ones like girl and daughter, that means there's at least one female character in the story, are more likely to pass. Also mother, especially school, right? Lives, woman, these are words that are associated with it. And then on the other side, you have boy and son. It's actually interesting to me that, like, I would have assumed, okay, the story of boy could still be about, I do understand why, like, Earth and Agent, these tend to appear in action movies. Team and Police, all these are action crime movies. So they're definitely corresponding to genre. But son and boy, like those are ones that describe a male character. Yeah, that does make it, I guess, less likely there'd be a female character. I guess I just wouldn't have thought of it that way. I would have assumed that at least they weren't quite as far as like war and earth. So how can I? So here's the last question. Can I ask? How could I say? Are there words that indicate more or less likely the Bechdel test while controlling for genre that move past Bechdel test while controlling for genre? So this is the fun bit. Is we're going to use GLMNet. I should be using tidy models. I kind of use my old habits sometimes, just because I know my way around this workflow. But all right, so this is called movie words. So we have movie words, and we have movie genres. And the story is that for each of those, I want to say like select. We want to select the title and the word. Actually, distinct title word is probably pretty good. And then I want to say do the same for title and genre. And I'm going to rename these as feature. Why am I doing that? Because I want to combine these. I want to combine genres and words. So I can actually do bind rows. This is not the only way to do it, but it's one that I like. I like to create this table of features. So now I have movies and features, and I can also throw in actually like binary. In this case, I'll recognize the difference between a genre and a feature based on based on whether it's capitalized. But here I'm just like pouring them all into a great big bag of words and features. So then I can do something like this. I can say add count to feature and filter n. You need to happen at least 10 movies, or I'm not even going to include you. Bingo. And now what we're going to use is a function called cast sparse from tidy text to say title. I'm assuming there's not multiple titles. Is that a fair assumption? It is not a fair assumption. Of course, this remakes movies like Carrie and Assault on Precinct 13. Instead of title, I'm going to use the IMDb ID, which will be unique. I might as well throw in the title, doesn't hurt. And it's always nice to see these. So then I can ask a question like, if I cast sparse of feature and over each row is one IMDb and each title is one feature. Now I have a matrix of 1587 movies for which we have a plot description and 366 words and genres. We're combining all of them. So now we're saying this is a movie feature matrix. Look at that. I've loaded up GLMNet, and the remaining thing that I need to do, and this is the one silly part of this process, you've seen me do this before if you watch this, is actually have in a private package I have a solution to this, but what am I even doing? If it's private, it doesn't matter. So what I can do is actually I can find the index and then match it up to the binary. So now I have a vector of pass and fail. Pass. So this is now my vector of 43% passes on like our 1500 observations. It's lined up one-to-one with the matrix. Again, this is kind of so I need to do this. And now I can do CV GLMNet, a cross-validated GLMNet, taking this matrix and predicting the true family equals binomial, and predicting the true effect. So I can say, okay, and I can say this is a regularized regression. I didn't have quite enough time today to talk through everything of what this means. What this is doing is it's saying we're going to turn up a penalty parameter, and as we do, we're going to then have fewer coefficients that have that pass your threshold. And then if I turn this penalty parameter down too much, this is what regular linear regression would get me: 360 terms. And you can actually see that it's a very bad model. This is the model if I didn't put anything in. This is the model if I put in some terms. This is the model if I put in every term, because we'd be overfitting. We'd have hundreds of data points and only like hundreds of features and like 1,500 data points. So what I can actually do is say tidy mod, so Broom has an approach for work with these coefficients. Tidy of mod geomnet fit. Now I have my coefficients for these different values of lambda. I've got other screencasts where I talk through this more. I'm a little bit low on time, so I don't want to overly focus on it, and only use the lambda that was selected. That's the penalty parameter or hyperparameter. And now I actually can say what terms and genres have an impact. And the top n absolute estimate. Oh, filter. I don't want to include the intercept. I have a board games analysis that use, as well as a wine ratings data set that both use GLMNet, and is really a blast. This was a mistake. It happened. Oh, I flipped these two. These are the 16 largest terms. Really surprising to me that action didn't pop up. I wonder, action and adventure didn't pop up. I wonder if, like, once you control for these, okay, well, let me do this by 20 just in case. What I can then say is, okay, estimate term geom call, and this is fun. All right, here we go. Here's our, this is fun because I can say word genre, effect on likelihood of passing Bechdel test. Really interesting to me that once you do this, the terms like action and adventure seem to have just dropped out. Huh. Because I would have said, here's my count feature. Action and adventure are very common. We know they have an impact. Well, it's in any case, it's interesting. What we can say is, okay, if it has the word girls, sisters, girl, husband, woman's, or if it's horror or slightly less trauma or comedy, it's more likely to correlation with passing the Bechdel test. And then we can say, heck, let me put in even more. Why not? I'm just letting the terms get closer to 0. What the hey? Why not? Okay, so you see, adventure and action still have a little bit of a coefficient, but words like girls, sisters, much more likely. Ones with that have a coefficient towards passing. Yeah. So this is a logistic coefficient. It means the change in the log odds ratio that a movie will pass the Bechdel test. So this was really this is pretty fun. We could keep exploring the model, add in a few other terms, but this is a way we can say, okay, it's not just the genre drives both the plot and the it's not as simple as the genre drives the plot and also has effect on the words. You can get more information from the words than you could just from the genre in terms of whether a movie is likely to pass the Bechdel test. All right, let's review what we did today. One step of cleaning with mutating across. A little bit of looking at time and creating this summarize function that let us say something like, okay, we probably want to filter for since 1990. Ooh, I did forget to filter since 1990 in our model. No time, we should remember that. Look at the top movies of all time. Did a quick box plot and then realized it would be better as a density plot. We knew we'd be doing a little bit of linear modeling today to see that, okay, there is a statistically significant difference between movies that do pass and don't in terms of their gross. But why? We discovered that indeed most if not all of the cause was genres. So we can see that, like, action, adventure, animation, all really likely all high grossing, all relatively low rates of passing the Bechdel test. That visualization showed it, and then I did a little bit of separate and spread, and I was able to see. I was able to do like a linear model where we said, okay, once we've controlled for genres, it doesn't even look like there is an effect of the Bechdel test in terms on gross anymore. But we were also interested in what's the reason that movies pass or don't pass, and we broke it down to a couple facets. We tried this facet first, but I actually liked it more. This was maybe besides the model, this might be my favorite visualization. What's that movies fail on? Because I said like has two women who talk to each other about something other than a man or pass, and where. The fact that romance is the one that's most likely to fail with there are two women, they're only talking about men, is an interesting insight. We looked at directors and saw that Steven Spielberg and Martin Scorsese really haven't had great representation in their narrative representation in their movies. And we took a quick look at writers, not quite enough people that wrote lots of things. And then we did a little bit of tidy text ending with this model. Yeah, this would be my favorite visualization of the day because I just do love, I love doing like a regularized model when seeing what the coefficients are. Lasso regression is just so interpretable. Again, if you're interested in lasso regression, I recommend checking out my board games analysis. Yes. So yes, that's it for today. I remember that you can find all of these on my GitHub, my data screencasts repository. If you enjoyed yourself, feel free to please do like and subscribe. Remember that from now on, these screencasts are always going to be at 4 p.m. Eastern time. So if they used to be 5 p.m. Eastern time, they're always 4 p.m. Eastern time. So please do tune in to that in the future. And yeah, I hope you had fun. I certainly did. I'll see you next week.